mathematics is 22. Cardinality for S is 18, and then cardinality for M intersection S, that is students offering both mathematics and statistics, is 10 according to the question. And then the universal set, that is the population of the class, is 40. Number offering mathematics will be the cardinality of M difference S, right? That's mathematics only, and that is given by this formula. The cardinality of the whole set of students offering mathematics minus the cardinality of the set of students offering both mathematics and statistics, and that's 22 minus 10. Let's see this on the Venn diagram. Look at 22 is for mathematics. Set of students offering mathematics, for instance, is the whole of this circle M, representing the set M, right? Is the 22 we are talking about. And then this place only, where my cursor is pointing at, is M difference S, which we just did now. We're also told that 10 students offer both mathematics and statistics. And then for statistics altogether is 18. And so statistics only will be 18 minus that intersection, like you can see here. Statistics only will be cardinality of statistics minus cardinality of mathematics intersection statistics, which is 18 minus 10, which is 8, like we can see. And then number offering at least one of the two subjects. If you are offering two subjects, take notes. It means you are offering at least one of the two subjects. So we need number of students offering one, number of students offering two as well. And so number of students offering mathematics only are offering at least one, so one of the two subjects. Number of students offering statistics only are offering at least one of the two subjects. We need to subtract the intersection, the cardinality of the intersection, because they are repeated already. They are already in these two sets, and that gives us 22 plus 18 minus 10, which is equal to 30. And that's the cardinality for mathematics union statistics, which invariably is the number of students offering at least one of the two subjects. Or you can also say number of mathematics only, which is 12, plus number of statistics only, which is 8, that's 20, then plus number offering both plus the intersection, which is 10. So 20 plus 10, you see, is also 30. So the two ways are correct. Then number offering neither subject would be the universal set minus the union of both sets. We've gotten the union of both sets to be 30, and universal set from the question is 40. So 40 minus 30 is simply 10. And obviously we have all our answers. First question, the answer is for only maths 10, only statistics 8, neither subjects 10. And this is the Venn diagram. As you can see, mathematics only 12, the intersection 10, statistics only 8, the difference sets like the universal sets excluding mathematics and statistics 10. So we move to Venn diagram for three sets. This is the general representation of the Venn diagram for three sets. You can see set A, set B, and set C, and then their intersections. We have this portion to be the intersection for B and C, this portion for A and C, this portion for A and B, and then this center for A and B and C. Let's see. All these explanations for the notations in the Venn diagram are straightforward, similar to the one for two sets. We have this formula which we call the empirical formula, that tells us the cardinality for the union of the three sets A union B union C is this given by this formula. Formula simply says we sum up the cardinality for each of the sets, that is cardinality for A plus cardinality of B plus cardinality of C. Then we subtract all intersections, subtract the intersection for A and B, intersection for A and C, intersection for B and C, and then we add the intersection for the three sets. So that's the summary of the formula. Let's see an example and we round up the Venn diagrams. In a class of 50 students, 28 offer maths, 24 offer physics, 20 offer chemistry, 10 offer both mathematics and physics, 8 offer both mathematics and chemistry, 6 offer both physics and chemistry, 4 offer all the three subjects. We're told to find the number offering at least one of the three subjects and then the number offering none of the subjects. So to the solution, of course, from the question we have three sets, obviously mathematics, physics, and chemistry, which we are representing with these letters M, P, and C respectively. And then the general formula, the empirical formula, will be this way. So A in this case is M, B is P, and C remains C. So the formula is this way, and then we can substitute values from the data we have in the question to get this union. This is actually a very good first step for solving Venn diagram problems involving three sets. Just use your empirical formula and try to solve for the left hand side with information you have from the question and see if you have a result. Luckily, here we have a result. Cardinality for M is 28 from the question. Cardinality for P is 24 from the question. Cardinality for C is 20 by given in the question. We remove those intersections. M and P, mathematics and physics is 10. We subtract. Mathematics and chemistry 8. We subtract. Physics and chemistry 6. We subtract. And then we add the intersection of all three, which is 4. And so we have at the end of the day that the cardinality for the union of the three sets is 52. And that's the first question we're told to solve, luckily. Number offering, no. The first question says the number offering at least one of the three subjects. Um, yes, it also interprets to this at the end of the day, the cardinality of the three and the union of the three sets, right? Because inside this union, every of these 52 students offer at least one of the three subjects. So students that offer at least one of the three subjects are captured in that union, right? If you offer two subjects, you offer at the same time at least one subject. If you offer all three subjects, you offer at least at the same time one subject. So that answers the first question. The second question, the number offering none of the subjects, we just subtract 50. 50 is the cardinality for universal set. We subtract the the union, the cardinality of the union of the three sets. We subtract that from 50. But 50 is less than 52, which is not logical. The number of students in the class has to be higher or equal to at worst than the number of students offering the three subjects, and so we conclude that this data is not consistent, right? So data is not consistent because the least number of subjects you can offer out of three subjects is one, right? And we have the population that offers at least one, which is 52 already. And then if you are offering none, it means you are offering zero. Zero is the only thing that is less than one in this instance. And it means if we are to have people that are offering zero, then the number of the population of the class should be higher than 52. And so that's why I would say the data is inconsistent. The population of the class is incorrect. So we'll stop here for today. You can go through the next example yourself. It's just very similar, and here are some exercises for you to practice. You can pause the screen and practice at your free time. Thank you.